I can't believe I brought my expensive boots just to be stuck behind a podium. Thought I was going to be able to flex on you guys, but that works. My name is Parker Brewster. I'm here on behalf of Interval Therapeutics, as seen here. And so because we're working on this platform technology with many applications, I wanted to zoom way back and talk about the different issues here in the clinical space. And so with drug abuse, in the realm of drug abuse, we're all keenly aware of the devastation arising from the opioid crisis. And in a similar vein, we have millions of desperate patients seeking illegal or controlled drugs to self-treat, a situation largely contributing to the fentanyl crisis. With intentional non-compliance, we routinely witness issues arising from psychiatric and pediatric patient classes refusing to take their prescribed medications. In some cases, we know that non-compliance can be a good thing. I imagine some of you have chosen to not take a medication you're prescribed because of some side effect. But when you're talking about patients with some level of mental incapacitation, that needs to be addressed. Similarly, with accidental non-compliance, psychiatric, geriatric, pediatric, and even just your plain forgetful, such as myself, struggle to adhere to a prescribed schedule, even when they know it's what's best for them. And finally, as AI drug screening gets better and better, we're getting more and more medications, which is, of course, an excellent thing. But that also means we're getting more and more complicated dosing schedules and regimens. Polypharmacy is the hot word there. And then beyond that, we have treatment protocols that are requiring outrageous injection schedules like in vitro fertilization. And so the kind of question I have here is what solution could possibly address all four of these, this kind of complex matrix of clinical shortcomings? And that's actually a bit of a lie. We're not to the big reveal yet. And also, sorry about that. That's meant to cover up an AI blurb on a picture you'll see here in a second. So start with microneedle patches. Microneedle patches are incredible pieces of technology, but they have shortcomings and the potential for abuse there, as well as dosing longevity. We also have smart sensors, assisted living programs, notification programs, and smart pill containers that, again, are all awesome tools for boosting compliance, but have their own shortcomings and issues with abuse. And then more recently, we've gotten a few different FDA-approved implantable drug delivery devices, and they have kind of two big shortcomings. One is the drug types that they're compatible with. The other is the big one for us, and it's that they're almost all constant release. And with many dosing schedules, you cannot have constant release. It's toxic or does not produce the desired effect. And so now we've kind of landed on the big reveal here, and I want you to picture that top graphic of your average weekly pill container and reduce that to the size of a large grain of rice. And then imagine that degrades like the fuse on a firework. And so if you look at our CAD of our devices here, our devices work very similarly. We are using a surface degrading polymer to act as a fuse. And so in that top design, our surface degrading polymers laid over drug loaded reservoirs. And as that degrades in the body, it releases the drug load. And the design just under that, the device itself is made out of the surface degrading polymer. And so that kind of goes back to the analogy with a pill container. As it degrades, your drug load is released for that day. What's cool here, and kind of what are the nuances there, we've got two components here, that's it. So it's a surface degrading polymer and then some slower degrading polymer, and the two are both biodegradable. And so after implantation and after the dosing schedule is complete, there's no retrieval necessary. The other cool thing is they're massively versatile, and there's all sorts of fun schedules you can achieve here. And so the first one there is just very standard, one drug, same dose, maybe once a day schedule. The second example there, you could have two different drugs pulsed in series. The third's really interesting. You have two different drugs at two different dosages at two different schedules. And then the fourth is what we're really excited about because, as I mentioned, this operates via a surface degrading polymer. And so within that matrix, you can actually load a different drug of interest and achieve zero order release or constant release while still achieving pulsatile release of the drug load below. And then in use case 5, if you guys have ever had to take steroids from those blister packets and they tell you to take 6 today, 5 the next day, 4 the next, this implant could achieve that. All right, so we have been fairly successful in securing non-dilutive capital to further our exploration and development of our novel platform. Not shown here for the sake of time, our first now published model for pulsatile delivery showed both in vitro and in vivo proof of concept. And our presented model has now demonstrated convincing in vitro proof of concept. We recently got SMART Act funding that is from the state of Mississippi that we're largely using for animal studies. And then STTR through the NIH funding is largely being used to further refine the devices and explore those unique dosing schedules. There's, of course, myself, Parker Brewster, but I'm not important enough to make this slide, so you won't see my picture here. I'm the acting vice president of R&D and have 6+ years of experience in venture capital. I'm also the founder of a venture studio, and I think I've talked to you, some of you guys in this room about that. But to better introduce Integral Therapeutics powerhouse team, we have Dr. Werfel as well as Dr. Walker. Dr. Werfel is an expert in drug delivery and nanotechnology. Dr. Walker is an expert in microfabrication and biotransport, and they both completed their postdocs at Vandy. And then we have Dr. Puleo, who was actually the pioneering researcher in the usage of surface degrading polymers for drug delivery. And then we have Dr. Munivar, who is a medical doctor who received his MD and residency from Yale. Why are we here? Particularly given that we're pre-animal studies, it might feel premature for us to present to you today, but we genuinely just wanted to be here to see the really cool things that you guys are doing in the region, and then selfishly to better understand the various funding pathways that you guys have taken to get there and to move it forward. We won't be pursuing dilutive capital for at least another 10 months and probably even further than that. But with my years of experience in VC, I know how important it is to be building those relationships early on. And then perhaps more importantly, we feel that our platform, given its massive application in a number of fields, makes us a really valuable candidate for industry collaboration and partnerships. We truly appreciate your time. And if any of you want to chat, you can connect with me on LinkedIn with a QR code or shoot me a text there at my phone number. Thank you.
Questions? Oh, took me a minute.
Hi, I was wondering how much variation there is in the kinetics of your degradation of the polymer across different individuals and what's acceptable.
Yeah, so a lot of these surface degrading polymers are extremely enzyme specific. Ours is not so enzyme specific. And so changes from individual to individual don't seem to make as much of an impact as it could with those other polymers. But we've only done very minimal rodent models for this polymer. And so we can't tell you exactly if there's a significant difference between, but with the resolution that we had in our release studies, it looked as though there was no difference.
If you in patients with this and you're putting a drug in them and they had an adverse reaction, how easy would it be for you to get this thing out?
Yeah, so it is surface level. There's no external procedure you could do
So it's just
to
sitting
stop
on the
this, but it's sitting just under the surface.
Get my steps in.
Good morning. Is this primarily for short-term use, or could it be for people who need to take drugs every day for the rest of their lives?
Yeah, that's a great question. And my PIs would tell you something different than what I'll tell you. They're really optimistic and are hoping to get a year out of one of these implants. For me, as the person that's in the lab every day, my expectation is that we'll be able to get 3 months out of this. And so one implant could get you a 3-month coverage. And so for me, I have to take a medication every day. I would definitely do that because it's not as involved as, say, Norplant, where it's an incision you're making to push a matchstick size device in there. This fits in a syringe, and so it's pretty easy to manage.
Thank you.
Thank you.